So, hello everybody. In this session, I'm going to talk about the Project Euler problem 70 of it. Let's see the question. Okay, if the numbers 1 to 5 are written out in words, 1, 2, 3, 4, 5, then there are 3 plus 3 plus 5 plus 4 plus 4 equals to 19 letters used in total. So if all numbers from 1 to 1000 inclusive were written out in words, how many letters would be used? So there's a small note down there, do not count space or hyphens, which means that when you count 1000, you don't need to count the space between it. So for example, 342 contains 33 letters, which means that you are going to ignore this contain 23 letters and 115 contains 20 letters. So this is 3, this is 7, 10, then this is 3, and this is 7, which makes up 20 in total. So the use of n when writing out the numbers is in compliance with British usage. So for this question, you need to convert the numbers into English in words, and you need to calculate how many letters used in these words. So now we have several cases. The first case is that from 1 to 10. These are 1 to 10. I'm storing them into an array so that I can use it for, let's say, 21. We can use 21 instead of retyping it. We can use the algorithm to build them out. So for 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for 11, 12, these are the special case. Other than you have 21, 22, 23, 31, 32, 33, this is the special case. So after declaring this, then now, okay, for 21 to 100, we are not calling 100 here because it is another case. So let's see how the algorithm works. We are extracting the digits, the first digit and the last digit here. The first digit here, I use I divided by 10 times 10. Let's say I have 21. 21, the first digit will be 2. So 21 divided by 10 times 10 equals to 2. And the last digit is 1. I'm using the modulus of 10 here. So after building that, we will get 20 here, 20 and 1. So we will refer back the 20 to the value that we have been stored here. 20. So 1, how about 1? 1. So let's say I have 31. So it will be 30 and 1. So I refer back the value in 30. So this is the value 31. Let's say I have 37. Then I'll get 30 and 7. After that, we store the value, the words of the digits in an array. After that, we will cover the case of 100 to 1000. We don't need to cover 1000 here because I have covered it earlier. So we just need to cover from 100 to 999, just like this. So in this part is a bit tricky. We need to change a bit here. Let's say I have 987. So first I will get it I divided by 100. So 987 divided by 100 equals to 9. After that, add 100 because 900. And after that, we get the remainder. So it is 87. So if the remainder exists, so we need to add an n after the 100. And then we will add the 87, which we compute it earlier here. If the number is like 700, so we'll here it will calculate the numbers into 7, so we will get 700. After that, there's no remainder after dividing 0, so we are going to ignore the n. Otherwise, we need to add an n words after the 100. So after that, this is the alphabet count, which stands for the answer, because we are fighting for the letter used from 1 to 100 when 1000 when expressed in words. So now we are going to look through 1 to 1000 inclusive to calculate how many letters are used in expressing the digits in words. So I will add 9. Let's say the first look for 1, I have 3, so alphabet count equals to 3. And the second one, 2. The length is 2, so we will add back to the existing value, which will become 6. And 3 is 5 letters, so we will add to the existing value of 6, so the value will becomes 11, and eventually we will get the total number of letters used, which is the answer. Let's see. So the answer is 21124. Let's check the answer here. Yes, this is the answer. So that's all for this question. Number letter counts. See you guys later.